Good morning, everybody. Thanks for joining. My name is Arkadiy Zgonikov. I'm an assistant professor at the Department of Cognitive Robotics here at TU Delft. And I'm also a co-director of the Center for Meaningful Human Control. It is my pleasure to welcome you all to today's seminar, which is quite special on several accounts. Well, first, it is special because today is the first ever joint seminar of the TU Delft Robotics Institute, the Center for Meaningful Human Control, and the Autonomous Driving and Simulation Lab. We are especially grateful to the TU Delft Robotics Institute for generously supporting this event financially. Second, and basically the main reason why today's seminar is special is because of the speaker we have here with us today, Professor Missy Cummings. Professor Cummings has one of the most unique backgrounds you can find on this planet. She started her career in aviation as one of the first female jet fighter pilots in the US Navy. She then moved to academia, where she did a PhD in systems engineering and has become one of the world's leading experts on human autonomy interaction and safety-critical AI. The work of Professor Cummings has been not only of high academic quality, but also has major impact in the real world. As an example, she served as an expert witness in a number of landmark legal cases involving crashes of automated vehicles. And recently, she was also a senior safety advisor at the National Highway Traffic Safety Administration in the US, shaping the future of automated vehicle technology in the States. Professor Cummings doesn't just ask what AI can or cannot do, but also what it should or should not do, and how we can ensure that not just AI safety, but also human safety in the presence of AI. It is a real privilege to have you here with us today. Please join me in welcoming Professor Missy Cummings.
Thank you. Thank you for the invitation. This is not my first time at TU Delft, but I always love coming back to the Netherlands. And yes, you heard about my background. Indeed, I do think that the thing that a lot of people find the most interesting about me is that I flew jet fighters. I'm old, which is to say I flew A4s first, which were in Top Gun 1. And then I flew F-18s, which was in Top Gun 2, so I find that that's how most people relate. I cannot stand to watch either movie, by the way, because it's not really at all like reality. So that's like torture for me, actually. But I learned a lot. I learned a lot about going from manual to automated control, problems with human-machine interaction. In my time flying fighters, on average, somebody died every month for the 3 years that I flew fighters. So that's 36 people died because of bad human-machine interaction. And that was the impetus for me to go back to school, get my PhD, which is unusual at that stage of life. And then I joined academia. The first 10 years of my research were really around unmanned aerial systems, which you know as drones, but I was doing it way before you ever even knew they were a thing. And indeed, in around 2012, 2013 timeframe, small drones were commercialized by Amazon, Jeff Bezos. And when that happens, it starts to change the way that you as an academic, because I'm supposed to be forward-looking. So, you know, I felt like, oh, I needed to get a new career, a new focus for my career, and that turned out to be at what would become self-driving cars. But this picture's from research that was paid for by Google X, which would eventually become Waymo. And we were exploring, and this is in the 2013, 2014 timeframe, we were exploring what people would do inside of cars that had varying degrees of automation. In this particular case, the car is, you know, you can think of like a level 2, level 3 car where it's doing most of the driving, and you just sort of need to pay attention and intervene when something bad happens. And in this case, a moose would just walk across the road after about 2.5 hours of driving, and it was totally avoidable. You should, if you were paying even the least amount of attention, you should be able to get around it. And 29 out of 30 people ran into the moose, And when this guy ran into the moose, you can see, what does he bring up? His phone, right? So this was autopilot before autopilot was ever a thing for Tesla. And then you can see, we knew then, and there's been plenty of research. By the way, I don't do research and distraction anymore because I know the answer. Yes, you're going to be distracted. And yes, the more automation that you put inside of a cockpit, the more you're distracted. The funniest thing that I've heard this week is if you haven't heard, I think it was a Spirit Airlines pilot get totally yelled at by air traffic controllers. He's doing something, taxiing, and the air traffic controller in America comes around and says, "Get off your iPad and listen to me." And I think a lot of people found that, it is a thing. It's actually a real problem in America, and I'm sure in everywhere else, that pilots are texting while taxiing. Like, that's how bad it is, right? But that's how much our brains are wired for stimulation. So I think it's really, and this is a good example of why it's important to think about the human in context of what automation and AI can do. And when I talk about automation and AI are not the same thing. Automation I consider rules-based, which we're going to talk about in a second. Autonomy is where there's more reasoning done by automation, maybe with some primitive sensors or maybe some advanced sensors. And artificial intelligence is a form of autonomy where you're trying to mimic intelligence in a way that is useful for whatever task it is. So let me just explain. This is the framework that basically guides my whole career. And I I basically developed this based on work that Jens Rasmussen did. So kind of in your area, I found that what Jens Rasmussen did was so important that I extended some of his work to be able to explain what's happening with reasoning and any kind of agent that has to reason in a world with uncertainty. So that could be a human, but it can also be AI. So at the lowest level, we have skill-based reasoning. When you first learn to drive a car, for example, you have to see the white lines on the road, and you have to actually concentrate to stay centered in those white lines. But only after a couple hours, it's highly automatic in you. And you don't have to tell yourself to stay centered in those white lines anymore because it was a learned process that became second nature to you until you get old. Then when you get old, you have to start paying attention to more in the white lines because your sensors degrade, your eyes get worse, your brain slows down. And I've seen it here. It's kind of funny, like when I go to different countries, I like to measure how much you've got the ping pong off the lanes. Boing, boing, boing. You can tell as people get older that they're struggling to do something that was once highly automated. That's also true for autonomy, and we'll talk a lot more but artificial intelligence, as long as it can see those white lines, will always do a much better job tracking the white lines than humans ever could because they are able to do millimeter precision accuracy and they are not on their cell phones. All right, rule-based reasoning. Once you've learned how to do the skills in your world, then you graduate to something we call rule-based reasoning. It means that you now have your spare cognitive resources. You don't have to think about tracking the lines anymore. You can actually start looking at the signs, symbols, signals in the world and figuring out what those mean. And they're there to reduce uncertainty. In America, when we first put cars out on the road at the turn of the century, 18 to 1900s, people crashed into each other like crazy because there were no rules. So we figured out, okay, we need some rules, like a stop sign, to make sure that it can control their behavior in a way to control for uncertainty. Now, once you've learned the rules in your world, they also become second nature, and then you can graduate to something we call knowledge-based reasoning. This is judgment under uncertainty. This is when the world doesn't exactly match what you've learned, but you learn how to adapt. In this case, up here, I show a stop sign partially covered by leaves. When I flash this slide up, all of you instantly knew. Even if you do not drive, you actually know what a stop sign is because it's just been part of your world existing. And, if you'd only seen a tiny bit of that sign, you would have known it was a stop sign. But this is where we start to see AI especially fall apart. These leaves that grow across the sign, in spring, they are not there. The sign is clear, and AI can recognize it wonderfully. But as soon as those leaves start to march across the sign, and they will grow and maybe almost cover the whole sign by the end of the summer, that growth and that partial obscuration is enough to kill AI. This has been shown over and over and over again, that signs that are obscured in some way are very, very hard for AI to recognize unless they're not explicitly trained to see the different partial presentations of a sign. And the problem with that is leaves don't always grow back the same way every summer. Every year they all grow back in a slightly different pattern, and that's enough to confuse AI. So in your mind, there was no uncertainty, but it's actually quite high. The obscured signs is a huge problem for AI and something that we have not been able to figure out how to generalize. And then last but not least, at the highest level, where we have what we call top-down reasoning, the idea that you can reference experience in the world to try to inform a new situation. This is a real intersection, or at least it was, somewhere in America at some point in time. I have a four-wheel drive, so I'm one of those obnoxious Americans that thinks I can go anywhere in my four-wheel drive. And I have definitely ended up in places like this where I shouldn't be. And if you find yourself in a situation as a human, if you found yourself in this intersection, what would you do to get out? Reverse. Who said it? That's right. Because in your mind, you're like, look, I got myself here on one path. I know for sure I can get back on that same path. That doesn't seem like a big mental leap, but this situation for self-driving cars, at least by today's architectures, it would cause the car to brick. Brick is the phrase that Silicon Valley uses to say that the cars freeze because they cannot figure out a path. Now, it was very quickly said, you said, go backwards. Cars don't, AI doesn't think. If you don't remember anything else from this talk today, you need to remember AI does not think, it does not understand, it does not know anything, it does not reason, especially under uncertainty. I know some of you might want to arm wrestle with me over, well, learning statistically is reasoning. No. It is not reasoning under uncertainty in the ways that we need to actually reason in the real world. And indeed, one of the problems with AI is that as the uncertainty grows, really somewhere between rule and knowledge-based reasoning, the systems fall apart. For now, I'm not saying they will always be that way, but if you need judgment under uncertainty, and the uncertainty can come from the environment, what I tell people, the graduation exercise for a self-driving car, Boston in the wintertime. That is the hardest place to drive ever. It is the hardest place to drive on a nice, bright, sunny day with no construction, but Boston loves to move construction zones almost on a daily basis. And also, the snow, rain, ice, sludge is terrible there. So the environment's a problem. AI blind spots, which I'm going to show you some of them in a second, but the fact of the matter is AI doesn't know, doesn't think, doesn't reason, doesn't understand, doesn't have an imagination. That is why it could not deal with this situation very well. And last but not least, human behavior can cause so many problems. In a funny way, if you haven't seen the videos of people in Los Angeles on Waymos jumping on top of Waymos and then doing backflips off Waymos, to show that they can. Okay, I'm just telling you that's America, and totally foreseeable and kind of cute and funny, and also tells you a lot about how quickly people learn what the weaknesses are for self-driving cars. But again, uncertainty is the killer. We need to do a lot more work about uncertainty, and I'll come back to that in a second. So as part of my time working at the National Highway Traffic Safety Administration in NHTSA, I was in charge of analyzing The daily crash reports coming in about self-driving cars and cars with L2, L3 technologies. And so after doing that for a while, then I decided to put together an analysis to show you what's actually happening with the crashes. We could argue later about whether or not self-driving cars are safer than humans. I don't think that that's been shown. There's a whole group of experts that believe that it's not until the cars get to about 275 million miles in the US will you be able to make any statistically confident assertions. But it is instructive to look and see what's happening with the crashes. And you can think about them in three different ways. We have perception crashes. Does the car see the world correctly? We have planning crashes. The car sees the world correctly and then makes a mistake. And then last but not least, in this set of accidents in this database, every now and then there is a safety driver in a Waymo car because, for example, it is testing new software, they're doing some mapping, and you can actually see that in comparison, you know, this goes to show you humans are still accident prone. I have an 18-year-old that just crashed my brand new Honda Passport SUV. I would love to get rid of human drivers if I possibly could. It's going to cost me so much money to have that thing fixed. Okay, now, I'm only going to focus now on the autonomy crashes. The perception crashes are on your left, and then the planning crashes are on the right. Perception other, that means the perception crashes caused by, in most cases, the car did not see something that was in front of it. One of the things that we know about self-driving cars are they don't see long, skinny things very well. Waymos have crashed into poles standing, and they crash into gates that are horizontal presentations, right? They just don't see something that is right in front of them. But far and away, the biggest accident category is struck from behind, and we're going to spend a lot of time talking about that. The smallest planning accidents are what we call other, meaning the car just doesn't make the right choice for whatever reason. But last but not least, the other accident category is unexpected actions by others. This is high uncertainty situations where human drivers, pedestrians, bicyclists do things that are unexpected. I can't wait to see a self-driving car run around Delft. You guys have some aggressive bicyclists who are doing some things that even and I bike a lot, I do not see the same kinds of, like, you got some angry bicyclists here in Delft, and that's not gonna go well with self-driving cars. All right, now, the three different categories: Cruise, who got their permit taken away to operate in California, but they're trying to get it back right now. Waymo, the biggest performer in this area, and Zoox is a self-driving car shuttle that had just opened up commercial operations in Las Vegas, and these are considered to be the three most advanced companies about self-driving in America. So let me give you an example of what happened with misdetections. This is the car should see something that's there but doesn't. This car hit the back of this bus. We being the experts, thought that this accident was impossible. We did not think that a car with LiDAR that has millimeter precision accuracy on a sunny day, that matters, because guess what? LiDAR doesn't work very well when there's moisture in the air, which is here a lot. That is a big deal in a place like the Netherlands where it rains a lot. But on this day, very sunny, so we didn't think that this accident could happen. When in the accident investigation, it turned out that this Cruise self-driving car did not understand that the bus that it hit in this picture was an articulated bus, kind of the bendy bus. They're all over Europe. I have ridden them in almost every country I've been on this in the past couple weeks that I've been here. It never was taught that. It was never shown images of that in its computer vision training. It had only ever been instructed on regular single-axis buses. And when it saw the bus, initially had a big question mark over its head, but it saw the front of the bus and said, okay, I know what that is. And I know that buses are roughly 45-ish feet long, so I'm just going to draw a line, cut the bus off there. So the back third of the bus was invisible to it. Now, you're like, but it has a LiDAR on it. And indeed, the LiDAR worked perfectly the entire time. The LiDAR measured the distance between the actual back of the bus up until the point of collision. The problem is that in cruises, this is dumb engineering. Like, who's an engineer in the room? Like, come on. Like, LiDARs are really, really good sensors, as long as it's not raining. Computer vision sensors, really terrible. They have high failure rates, which we are going to see a lot over and over again in this talk. What they did is they said, well, the computer vision should be our primary sensor, and only if the confidence interval gets below 95%, then it will call the LiDAR. But if you know anything about computer vision, it's a neural net. Neural nets are like psychopaths. They're confident about everything they do. Just talk to ChatGPT. It knows everything. And it was 100% sure that its estimate of the bus was correct all the way until the point of collision, because it never called the LiDAR. So yeah, misdetections are a big problem, relatively speaking, but not as big as this problem, the struck from behind. So this is, I'm going to talk about a Tesla, because these cases are happening, they're very dramatic, and they're caused by computer vision problems. I do just want to say really quickly, on a timeout, Teslas are not self-driving cars, no matter what Musk claims, nor will they ever be self-driving cars, because they only rely on computer vision, and that is simply never going to be sustainable to have the kind of levels of reliability that you need for a safety critical system. In this particular case, there was a Tesla leading a pack of cars through the Bay Bridge Tunnel in San Francisco. The Tesla saw something. They won't tell us what it is, but there was nothing in front of it, but it saw something, and it caused the car to go from 65 miles an hour, 130 kilometers per hour, and then brake really suddenly, and then 8 other cars piled in behind. Because that's how fast and hard the actuation is. That is the problem with, these are known as phantom braking problems. When cars see something in front of it, they brake harder and faster than humans are capable of doing, and it catches everybody by surprise. Even if you're doing that 2-second following distance, which is what we're teaching people in America, that is still not enough to prevent a hard braking maneuver from causing some kind of pileup. Tesla is currently under investigation by the United States National Highway Traffic Safety Administration for these phantom brakings. That started under the Biden administration. Now that Trump's in office, we don't expect this will ever see the light of day. I don't think they'll get rid of it, because Musk and Trump are not friends anymore. But I don't think we're actually going to see this adjudicated anytime soon. But it's showing up in all self-driving cars. Anywhere where you have computer vision, it will show. It's showing up. It shows up everywhere where you have computer vision in general. I do some work on medical cases. Neural nets will hallucinate. ChatGPT and other large language models don't hallucinate. They actually just make statistical inferencing errors. These things really hallucinate. The way that the patterns are learned, sometimes and we think shadows have to do a lot with it. There's a lot of shadows in tunnels, but that's not the only cause. That's just one cause that we think we've sort of isolated. But if the shadows look like, for example, an elephant, even if it's not an elephant, that car is braking, and it's braking hard. That is what is causing all of those accidents for all self-driving cars. Indeed, we see that self-driving cars are rear-ended at twice the rate humans are rear-ended. And again, we know that it's because they're seeing things that aren't there, that the car is not reasonably able to determine. Even if you've got LiDAR, LiDAR is keeping the rate lower for self-driving cars than for Teslas, which is actually much higher than the numbers I showed you before. But it just goes to show you, even LiDARs can't sense the world correctly enough to always give you the right answer. Okay, so let's talk about some planning issues. So the car sees the world correctly. There's no perception issue, but then the car chooses to make the wrong decision. In this particular case, this is a Waymo. This is a very recent picture in Austin, Texas, where you can see the Waymo just elects to turn into traffic. The wrong lane. It's facing all of these other cars, and this is happening so often, both in California and Texas, it's leading to gridlock, because then the car has to get unstuck from this situation. Now, again, you're like, how did this happen? If you have all the right sensors, how would this car drive into, if you get at least three lanes of traffic? So the LiDAR knows theoretically that it's up against 3 lanes of traffic, and if it understood the rules of the road, it would not be turning into traffic. We, experts, not at Waymo, believe that this is a sign that end-to-end learning is starting to go wrong. So in the old days, computer vision was trained. You teach the car a bunch of static images. It learns how to see these images and classify them in the real world. Takes a lot of memory, takes a lot of time, and then you still have to layer in the planning rules and assessments of traffic flow. Now people think you can actually teach the cars using videos, and you label the videos, and then the cars learn dynamic forms of reasoning. It sounds good, also very hard to do, takes lots of memory, and we think that this is an indication that end-to-end learning is not going to be the panacea that people think it is, because now, for whatever reason it thinks that turning into that traffic is correctly and ignoring the other sensors that are clearly telling it. I mean, 3 lanes of traffic, that's kind of a big deal that it's turning into traffic. And last but not least, unexpected actions by others. This is the accident that caused crews to lose their permit to operate in the state of California and in the United States in general. So what happened was, it was at night, and about 9 p.m., and a cruise vehicle was on the right, like just behind a human-driven vehicle here. The light changes, and the cars roll through the intersection, and the Waymo immediately picked a pedestrian up jaywalking, stepping off the curb and gonna jaywalk at night across several lanes of traffic. Now, jaywalking is a thing. I have been doing an informal assessment during my trip through Europe, and people in the Netherlands are way, way, way more likely to jaywalk than in Vienna. I'm just comparing, and Sweden. Sweden, they don't jaywalk like I feel more at home here, by the way, because I'm totally a jaywalker. I don't have time for this. I don't have time to be slowed down, right? So it's totally expected, especially in San Francisco. So they roll through the intersection. It picks her up immediately that she's stepped off the curb. Now, if you were at night going through an intersection and you saw a jaywalker coming up, and it predicted that it was not going to hit her at the current rate of speed, but that the car next to it, the human-driven car, would. What would you do if you were presented with a scene where there's a pedestrian jaywalking in the street and you saw her cross? I'll tell you what's going to happen in Delft with those bikes. The bikes would totally speed up. I mean, aggressive. Like, it's funny, like, cars here are actually nicer than bicyclists. Yeah, so, I mean, unless you're a bicyclist in Delft, most of you would slow down, maybe honk the horn, try to, stop the situation from speeding, but, the car is very much like a Delft bicyclist, and it did speed up. So it closed the gap with the human-driven car. And she crossed at a very steady rate. She does get hit by the human. So she's crossing, and she kind of turns and sees the car, and she gets kind of hit by on her obliquely on the side, and then falls back in front of the self-driving car. Now, remember I told you they can actuate much harder and faster than humans can. It did. It did an emergency braking maneuver, and it was able to really dissipate a significant amount of energy. It did hit her, but she probably would have just been able to get up and walk away. So, you know, it was less of a hit and more of, I don't want to say a tap, but certainly not a full-on hit. But she falls underneath the front of the car. AI does not know, does not think, does not imagine, does not understand. She's out of the sight of the camera, it forgets about her, and it's been programmed, but its accelerometers went off, and it's been programmed that if your accelerometer goes off and it exceeds some threshold, then you need to pull over to the curb and talk to the remote operators. So decides to pull forward 20 feet and over and off to the side. She gets caught up in the undercarriage of the car, gets dragged, and then those are her feet under the back left tire. And she lived, but she was in the hospital for a year recovering from this. Lots of problems here. The car doesn't think, doesn't know, doesn't imagine, accelerates into a bad situation. Had it stopped or at least slowed down when it detected her stepping off the curb, this doesn't happen. Then the remote operations center, there was one. They actually saw and heard the whole thing unfold. But crews decided, against what they told the state of California that they were going to do, did not have either a big red button in the remote ops center to stop the car, because had they seen this evolve, they could have theoretically just hit the stop button and prevented it from happening. But they also decided to put it on a 3-second delay, the video feed. All of this to save money. So I feel bad for the remote operators because they saw, heard everything. They could hear her screaming. They could not do anything, and it was already too late by the time that they heard it, right? So this case shows you a lot of problems with the inability of cars to reason in the presence of uncertainty, but it also starts to highlight a major issue, which is what is going on with these remote operators, and what could we have done? Certainly the state of California just took crews at their word and never actually investigated whether or not they had designed the remote operations center with the big red button like they promised. So all of these cases combined really help you understand, you know, at the lowest level, the skill-based level, like, there's no reason the back of the bus ever should have been hit, yet there was a poor design choice to make that happen. Then we've got rule-based reasoning, cars turning into lanes of traffic. I mean, that's actually, when you see this accident, you're like, that seems so 2010. Like, those are the kind of mistakes that when they were first rolling out self-driving cars that they were making then. So the fact that we're seeing them come back starts to show you that if we're going to shift architectures and you're going to move away from rule-based reasoning, that you're going to pay the consequences. And then, of course, the pedestrian getting run over in California shows you all kinds of problems with judgment under uncertainty. Now, I want to focus in, since this is an academic place, uncertainty is the key here. It is the key not just for self-driving cars, it is the key for all AI that you're going to put in any kind of embodied robotic system. If you cannot control for uncertainty, then you have to really reconsider what is the right operational domain. Now, uncertainty can come into two forms. It comes into something we call epistemic and aleatoric. Epistemic uncertainty stems from, that word means knowledge, right? It stems from our knowledge or lack thereof in designing the systems. I would put the car hitting the back of the bus and car turning into 3 lanes of traffic under epistemic uncertainty. The car failed in those cases, but who's the real failure? Engineers. The weird thing about my position in life now is I produce many, many students who are now CEOs of major transportation companies or senior engineers who are doing things like run autopilot at Tesla. When I see their accidents manifest in the real world, I often consider, is this my fault? And should I go back and rescind a degree? Especially with these guys right here, the ones that put computer vision as the lead sensor. I'm like, oh, they're just so dumb. But dumb because we're not controlling for epistemic uncertainty. And I would tell you that is by far and away the biggest classification of uncertainty that we could and should be able to reach out. Why do we not control for all the levels, all the kind of epistemic uncertainty that we could and should control for? We'll talk about it in later, but money has a lot to do with it. The harder nut to crack is aleatoric uncertainty, because this is uncertainty that is part of the nature of stochastic processes. It's randomness that just comes from the world. It comes from data processing. It's not clear if you can ever control for, ever solve aleatoric uncertainty. And this, I would say, what falls into aleatoric uncertainty? Neural nets and hallucinations. Look, neural nets, hallucinations are two sides of the same coin. The other side of the coin from hallucination is creativity. You see in large language models that AI can come up with some really clever interpolations of the data that it sees, and we anthropomorphize and we say, oh, that AI is so smart, it knows what it's doing. No, it just statistically just came up with something that seems creative, but the same side of that coin is a hallucination. Sam Altman has admitted that his OpenAI has a 37% hallucination rate in any kind of summary of any sets of documents. And it's much worse once you take it outside of just summarization. And he's admitting that. I have to tell you, it's probably much higher. It is just a fact of life. In any kind of statistical inferencing, that's just the way it goes. Sometimes if the distribution is not exactly correct that's underpinning the whole set of reasoning, then you're going to pull from the wrong distribution. That just is never going to go away. So if we can't solve the aleatoric uncertainty that goes with neural nets, what we need to do is start learning how to manage it better. For example, can we make systems that understand when there's a much higher likelihood of hallucinations? Could we make a system that either did not let self-driving cars go through tunnels, or maybe put some new head beams and light up the world in a certain way on different frequencies to make sure that shadows, for example, are not part of the world? Maybe. So I think that there are ways that we can address it, if not solve it. All right, so that leads me to this slide. So you've heard me talk all about self-driving cars. So what does that really mean in terms of the rest of the world? So up here, so that I could talk to regulators and people who are not experts, I put this chart together to show people that on the y-axis, we've got safety criticality, and on the x-axis, we've got non-determinism, that degrees of randomness that show up in the world. And what you see is really up in the upper right corner, computer vision. Anywhere you see it, anywhere where you've got computer vision, you are going to be in that upper right corner. And so if there are humans involved that you can kill, it's going to happen eventually unless you learn how to control it. Up in the top right corner, I've been talking to two groups I've been in Europe now for a couple weeks. I'm either talking about self-driving cars or lethal autonomous weapons. And I tell the self-driving car people, look, it could be worse. You could be the lethal autonomous weapon. There are people in the world that think it's a good idea to put generative AI in lethal autonomous weapon. No one in Europe, by the way. Nobody thinks it's a good idea in Europe. It's the US. Donald Trump thinks it's a great idea. So I'll leave that there. And what that also means is one of the things where we as an industry are failing, it's true in Europe, it's true in the US, less true in Europe, but still somewhat true. So we're not doing enough research on testing. So these are 9 what we call technology readiness levels. And the way that the US works is academia is responsible for 1 through 3. Places like TNO are responsible for 4 through 6. And then companies are responsible for 7, 8, and 9. The National Science Foundation in America just recently said that safety is not a legitimate field of study. I disagree. I don't think Europe has the same approach. That being said, people are not funding safety research enough, and more explicitly, funding test and evaluation of AI. It gets no funding in the United States. It gets very little funding at the TNOs. They do a little bit of it, but they can't do everything. And then companies are not incentivized to test at all because they're, especially in America, it's a hyper-competitive world trying to get products to market. So we as a community, academia, the technology matures like TNO, the companies, we all need to do better at formalizing test and evaluation. I put together this slide to show you one of the ways that I think people need to think about it too is how can you think about safety and where does testing come in when we think about safety? So these are the Swiss cheese models of Swiss cheese model of accident causation, where every major crash, and this comes from the airline industry, there's never just one cause. It's a set of causes. It's a systems approach to safety where the loss, the crash, for example, there's a proximal cause, an unsafe act. In the case of aviation, for example, the pilot forgets to put the flap switch down coming in on landing. So that was the cause. But before that, you can appreciate, well, maybe that pilot did not have his crew rest last night. And indeed, it is because of all the problems caused by a lack of crew rest that now it's mandatory. But we would call that a precondition for an unsafe act. Then before that, well, there's unsafe supervision. Maybe the supervisors aren't making sure that the pilots are getting enough rest. And then before that, Spirit Airlines. We love to talk about Spirit Airlines is the one airline in America that we all love to make jokes about because you know, they're unsafe and just terribly generally to fly on. And organizational influence, like they're really desperate for money. So they cut corners, for example, when they're really desperate to make money. And that is, by the way, every company in self-driving and really in tech right now. The people who need to make the most money in tech right now in America, generative AI companies. OpenAI is hemorrhaging money. Any company with a large language model is desperate to monetize the fact that they're spending billions of dollars to train their models. They're not recouping their losses. But this then, so I rethought that, reimagined what that model would be, because while the Swiss cheese model is good, the standard one is good for human-driven accidents, when you have AI guiding a system, now you don't have a human to blame, so how can you rethink those layers? And testing now replaces that unsafe act. Testing is your last barrier, your last slice of cheese before an accident. And if you're not doing enough testing, then for sure you're going to have a gaping hole. Now, behind that, we have inadequate AI maintenance. Companies do not want to retrain their neural nets as much as possible, no matter what field you're in, because it's expensive. Inadequate AI design. You should not be putting a computer vision system as your primary and only sensor ever. This is how I know that Tesla self-driving cars will never work on their vision system. Never. There's no redundancy. The reliability is terrible. I mean, forget 10 to the minus ninth. We're at 10 to the 1 on this thing. You're for sure going to have an accident, or 10 to the 0. All right, and so, behind that, and inadequate AI oversight. Companies are desperate to make money. Self-driving cars, hemorrhaging money. Generative AI, hemorrhaging money. This is one thing that people do not talk about, is that there is so much money being hemorrhaged that it's not clear that any of these businesses are going to scale. Waymo just had to move its entire remote operations outside of the United States. They are now parked in the Philippines. And one major cause of that is they're trying to save money. Because, by the way, there is no such thing as a self-driving car in any country. They're all heavily babysat by these remote operators. And if you need 3 remote operators to babysit each car, this is not a cost that's going to scale. I don't know if that's what Waymo's doing. They won't say how many operators they have per car. But if you're not going to be able to be honest about what's happening in remote operations, you're also not going to be able to scale your business. All right, so I'm going to stop there, and then we can take questions. I will skip that for now. All right, because I know we've only got about 10 minutes for questions. I can do it. I can just, you know.
I think we can keep your mic with you.
Okay.
Hello? Hello? Yeah? Does it work? Okay, any questions?
I see a couple of guys in the very back over here.
Thank you for the presentation. I work here at Delft, and I also do a lot of research with industry. And of course, your message is we need to be very cautious with the industry because they clearly have interests. And I wonder if you have some advice for us on how to engage more meaningfully with industry as academics and ensure that when we do collaborative projects, when we really work with them, we can actually do it ethically and responding to all these concerns that you highlight.
Yeah, it's a great question because you want to work as a young student that you're just learning how to build computer vision systems or planning systems, and it's really exciting to get into this field. You don't, this is what I tell my students in class, you don't ever want to be the student that I use to hold up as an example when I teach these classes. It's hard. It's hard because if you get in with a startup company that's brand new, I think that that's the most fun for students and has the most promise, because if a company is new, they haven't yet really kind of established what it means to make profit. So they're not under the same pressures that they are later. And I think that's one of the big things. I've had a ton of students, for example, work at Cruise. All of them went early on in Cruise where it was fun, it was more of a startup culture, and then they all quit as Cruise was getting closer to actually deploying for a lot of the same reasons. You would not believe the number of emails that I get from people around the world who said, I used to work for a company X, and you are 100% right that all of this stuff is going on. So I do think that there is a big concern for students. I would say, you know, you have to be very circumspect about, you know, thinking about, you know, give a company a chance. I think you have this problem less in Europe, though, just in general. I just feel like US companies, because of that hyper competition, whether it's in self-driving cars, robotic surgery, for example, manufacturing warehouses, I think that, you know, this culture here in Europe is just more mindful of that than we are in America, where we have a race to make the most money. And certainly we're at a time where when you saw Donald Trump get sworn in, all the tech CEOs are right there with him. But I recommend voting with your feet. Give a company a chance. Try to make sure that, you know, you don't feel ethically compromised by working with that company. But at some point, you might have to make a choice to move on. But I will tell you, like, for example, I work with Palantir. I'm an advisor to Palantir. There's a very unpopular company in Europe. I would recommend that you go work for Palantir because even as crazy as their CEO is, Palantir has an entire division called their Civil Liberties Division, Privacy and Civil Liberties Division. So they recognize that they're really in some ethically gray areas, and so they at least have a division of the company that is trying their best, maybe not always succeeding, but trying their best to kind of keeping the company on a narrow path. That Palantir model is a model that I'm trying to get more US companies involved in, right? Because at least having the discussion about privacy and civil liberties is better than being in a company that is just going to run roughshod over that regardless.
Thank you.
It's not a very satisfactory answer, I'm sorry. By the way, there's almost always a conflict between ethics and making money. That just exists in all fields, right? You got to try to find the right balance.
Other questions?
Oh, yeah. He's coming.
Thank you. So I was wondering, based on what you've told us now, like, what would be the most urgent things that we need to fix regarding remote operators? It's like, what would you say, okay, start here, these 3 things.
Yeah, for remote operations, number one issue that needs to be addressed is professionalizing them. And what does that mean? To make these, they are like dispatchers of aircraft. The FAA requires that if you're a dispatcher, you're working on scheduling, or you're in that loop at all, you have to be drug tested, you have to have training, you have to be licensed in that field, right? So the companies hate it, and I always tell people, like, if I mysteriously die, first of all, Elon Musk did it. Who's the second person that killed me? Probably Waymo and the self-driving car companies, because they do not want you to start professionalizing dispatchers, remote operators. It's just extra cost. But I come back to them and I say, look, if you're at the point where you're talking about professionalizing a group of people, it means that your technology is maturing. And if you're going to, you know, I say, if you're going to put your big boy pants on and say that you're going to operate in a safety critical system, then you need to just expect and accept the fact that, okay, we're going to professionalize this group of people, and that's what we should do, because not only does the regulator ask for it, but it helps engender public trust.
Thank you. Other questions?
See, now you guys are getting warmed up. Like, at first, you were a little afraid of me.
Okay, yes. Thank you for the very nice talk. So I was wondering, what are your thoughts about the planning under uncertainty? So for instance, you gave the example of the Tesla car that could have it stopped because it saw something. Could have been a bug or a cigarette, who knows? But the question is, how should these cars, or what are your thoughts about the planning under uncertainty? They could be, maybe wait until perception is perfect, or they can be more conservative and stop for anything, like might have happened in that Tesla case, or do contingency planning or something else, but that also relies on models from the perception. So do you have some thoughts on how this should be addressed from the planning side?
So planning under uncertainty it is a big subfield inside of AI. In fact, I work in that area for a lot of the research I do. You know, you actually gave some of the answers yourself, like maybe we had better contingency modeling, sensor fusion, doing better sensor fusing, or in the case of Tesla, doing any sensor fusion, right? Like all Tesla needs to do to immediately improve their safety is add some other sensor to help them get a better, what we call, world model. A world model is for how any robot represents the world so that it can figure out how to move in the world. So the richer the world model, the more likely you are that you're going to have correct interpretations. We will never achieve perfection in a perception system, and we should not require it. I'm a big fan of, at least in driving, look, if you're better than my teen daughter, then I'd rather have a self-driving car. That is not a very high bar. When I ask that same question in Europe, I hear 2 times safer than humans. Okay, wherever you want to draw that line is fine, but I think we need to be realistic that humans are probabilistic entities. Self-driving cars, other robotic systems are going to be probabilistic entities. For whatever domain that they need to operate in, they should their behavior should follow a set of reasonable expectations. And this sounds like a regulator talk, because it is. So we have to determine what is reasonable. But one of the things I'd like to see the planning under uncertainty community do is more testing, because academia is the worst at, and especially in America, we are going to do a very cool demonstration. I'm going to take this robot and I'm going to generate 1,000 hours of experimentation robot to get to that 1 minute I'm going to put on YouTube. Like, we all do it, by the way. Like, I see a lot of shamed faces. Oh, busted, right? I mean, we do it because we are trying to capture the spirit and excitement about the possible. But at the same time, we as academics need to be more clear that, by the way, when I tested it under sets of circumstances, that it didn't perform as well as I thought it would. We hate telling on ourselves. But the reality is we're also not setting expectations correctly, because your average person in companies and regulatory environments do not understand how bad computer vision is, and that is because we never write papers about how bad computer vision is. With the man with the mic.
Hi, I'm a master student here at TU Delft studying civil engineering, and I had a question regarding the interactions between vulnerable road users and self-driving cars. Now, assume, say, at a crossing, I feel that there's always a level of uncertainty in the mind of a pedestrian or a cyclist that say, when they see a driverless car, is it good for me? Should I cross now? How is the vehicle going to react if I start crossing now? And my question to you is, like, in your opinion, what could be done to sort of instill this level of confidence into a pedestrian, or say, so that they're fine with interacting with an autonomous vehicle?
So the pedestrian, vulnerable road user, I would put there the actually bicyclist also. And then another category, which is a big one in the U.S., are construction zones, right? Because all three of those carry significant uncertainty, and we've seen that cars do not perform as well as they should around these environments. To that end, Waymo is trying to develop better pedestrian models. You know, I think, you know, if you can track somebody walking at a certain speed, you know, there is some certainty about just how far they can go. But, you know, one of the problems with pedestrians, especially somebody like me, walk, oh, I forgot my cell phone, and then I immediately do a turn around and start reversing my direction. That's very hard for cars to understand, you know, what does it mean to understand intent? How do I model that? You know, I still think it's possible to put safe zones around everybody. Just model the entity, you know, and then some region around it, and just don't go in that region. That, of course, takes a lot of computation. This is one of the other things that I didn't really mention, but I really need to, and that is no self-driving car in America can work on the highway. And with any level of consistency. And the reason that's driving that is the speed of computation and those models, the decisions have to be so fast at 130 kph that we see a lot of wrong decisions happening because not only is there a significant uncertainty in behaviors, but the ability to actually compute quickly is another big problem. My connectivity friends want to say, well, we could just make that happen off the cloud. And I'm like, in the cloud, I'm like, no, you can't unless you can keep latency under 10 milliseconds. And that gets a frown. So yeah, I do think that that is a big deal. It is a bigger deal the faster that they go. And so that is actually critically where we need regulators to step in.
We have time for one last question.
Do you actually think it's a good idea to pursue automation, to pursue automated vehicles, not only in robotaxis, but also in trucking, public transport?
So, you know, I've given this presentation and you're like, oh, there are a lot of problems that require solving. I would step back and I would say philosophically, in America, we do not have enough truck drivers. And this demographic gap is only going to get worse over time. Indeed, the rest of the world, and it's hard to believe where we are now, but we are within 40 to 50 years of peak world population. That's incredible. What that means is in 40 to 50 years, all of the world is going to be on a population decline. It's already happening in some countries. France is in big trouble, for example. So even though we think, and I know with this world, I follow the immigration issues over here, of course, in America, but the reality is that in 40 to 50 years, there will not be enough people. And it's hard to get your head around what does that mean. It just means that we're going to need robotic systems. If we're going to keep up a certain quality of life, we're going to need these systems. So philosophically, I am behind it. Practically, you know, I worry that there's been so much hype around the technology that we're not being realistic about what is actually safe enough. Self-driving trucks, they have been shown to be a real problem in America for all the reasons that I've just talked about: speed of compute, not able to control for uncertainty, hallucinations. I do not see self-driving trucking in America happening anytime soon. The only way that I could see this realistically happening right now is if you had dedicated truck-only lanes. And there is, I mean, this isn't, I'm not the first person to talk about it. This research was proposed probably 40 years ago. So we're thinking about it, but I haven't seen anybody actually do it. Self-driving cars are a little bit different because Waymo has shown and continues to show that in urban slow-speed environments that they can pull it off. It's not clear that they can pull it off at scale and make it cost-effective. My favorite application are the shuttles, because I don't really think it's going to be cost-effective to have one self-driving car move one person like in America. But it does make cost sense if we have one self-driving shuttle move 10 to 20 people around. And I really do think, back to my civil engineering person, we could really revolutionize a lot of congestion, more efficient movement, safer movement, understanding that under slow speed, and if we can maximize the economies of scale, then there's a real win there. But the problem is Waymo does not want to hear that, right? And so Waymo is coming to a country near you because they're under pressure to also make money, and they feel like the more that they roll out, the more that this is going to happen. I just don't see how they're going to, they're hemorrhaging money. I don't know how much longer that's sustainable, but if I were to talk to, like all my other European friends, look, I would go all in on those shuttles. That can be done safe enough. And it's certainly, I think it's probable that we could see much more effective networks of shuttles in Europe before we would in America, because I think the European mindset is one of, we're all in on these moving people at scale, and also the collaborative nature. Instead of working, in America, the self-driving cars hate the regulators. It's a war, as opposed to, I'm hoping in Europe that people will see regulators and companies as a partnership to success, as opposed to some kind of fierce competition in the US. Thank you.